Hello friends, do you want to know about set instructions in relation algebra? Then join first. I am K. Purushottam from SVCE going to give a brief introduction on set instructions in relation algebra. In order to find out the common elements between two sets, the set instruction is a fundamental operation in relation algebra. This is a crucial step in data analysis, enabling us to identify shared information and draw meaningful insights from our data. Coming to the definition of set intersection in relation algebra. The set intersection is a fundamental operation that produces a new relation continuing only the records that are common to two or more inputs relations. The resulting set contains the elements that are present in both of the original sets. Let us explore it in detail. The intersection of two sets A and B is the set of all elements that are common to both A and B. Set intersection can be visualized using a Venn diagram where the overlapping region represents the elements that are shared between two sets. In the context of relation database, set intersection is a powerful operation for finding common records across the multiple tabs. Now let us see about notation for set intersection. In relational algebra, the notation for set intersection is the symbol as shown in the diagram is also known as the intersection operator. This symbol is used to denote the common element between two or more sets. The expression for A intersection B, as shown in the diagram on the left, represents the set of all elements that are common to both set A and B. Thus, operation returns a new set that contains only the elements that are present in both original sets. Hope the concept of notation for set intersection is clear to you all. Now, moving on to the properties of set intersections. We will first discuss on the properties of shared elements. The set instructions identifies the elements that are common to two or more sets. Thus, the resultant set contains only the elements that are present in all the input sets as shown in the first figure. These are two sets, set A and set B. But in the set intersection region, you can see elements of both set A and B, that is, set A plus B elements. The second property is commutative property. The set intersection is commutative operation. It means that the operation of set does not affect the result. It is like 2 plus 3 is equal to 3 plus 2. In set A, in, in set A intersection B is same as B intersection A. Third property is associative property. Set intersection is also an associative operation which allows us to perform intersection in any order without changing the final result. It is similar to algebraic properties that values of A intersection B is associative and the answer is intersected with C, which is same as intersection of set A with the result of intersection of set B with C. For implementing set intersection in SQL, we can follow the steps as shown. First is select clause. The SQL select clause is used to specify the columns to be included in the intersection result. Then from clause. The from clause specifies the two tables whose intersection will be computed. Finally, the where clause. The where clause is used to define the conditions for intersection, typically by matching common columns between two tables. These are various uses for set intersection. The intersection. The users can be in the field of customers analysis, where it helps to identify the common characteristics among companies, most valuable company customers, enabling targeted marketing and personalized experiments. Set intersection can be used in data deduplication to remove duplication of records from database, ensuring data integrity and improving the uh, reliability of analytic insights. E-commerce platforms use set instructions to identify products or services that are frequently purchased together, providing personalized recommendations for customers. Set interactions has following advantages. Precious results. Set integrations gives you extra common elements between two or more data sets, providing highly targeted and specific information. Identifying the commonalities by finding the intersection, you can uncover shared characteristics, traits, or relationship between different data resources, leading to valuable insights. Optimizing queries. The intersection operation is efficient and can help optimizing database queries, improving performance for complex data and tasks. Data validation. Data validation compares the intersection of multiple data sets, can help verify the data integrity and consistency, ensuring the reliability of your analysis. Now, let us move on to the limitations of set intersections. Limited scope. Set integration only consider the common elements between two sets, ignoring the unique elements in each set. Restrictive conditions. Set intersection requires that the operands have the same data type and schema, limiting its flexibility. Potential data loss. When performing set integrations, the resulting set may lose important information contained in the original set. Performance changes. Calculating set integrations can be computationally expensive, especially for large databases, which can impact query information. This slide gives us the comparisons to other set operations. The set integration is in a relation algebra can be constructed with other fundamental set operation. Such difference when union combines the elements of two sets and difference removes the elements of one set from another. Intersection identifies the common elements shared between two sets. Like union, which creates a new set containing all unique element, intersection only returns the elements that are present in both input sets. This makes intersection a more selective operation, useful for finding common data points or identifying overlapping information between different data sources. Comparing two sets compared to set difference, which removes elements from one set that are not found in another, intersection has more additive effect. It prevents the common elements rather than discarding them, providing a way to identify shared characteristics or attributes among multiple datasets. Finally, conclusion and key takeaway. This is a presentation. In this presentation, we have explored the concept of set integration in relational algebra, its notation, properties, and implementation in SQL. We have also discussed the use case and advantages of powerful set operations. Thank you all for joining my session.